Okay, sir.
Yeah. சார் மீட்டிங் வந்து நம்ம ரெக்கார்ட் பண்ணுறோம் சார். இந்த ரெக்கார்டிங் லிங்க்குமே நம்ம ஸ்டூடெண்ட்ஸுக்கு வந்து ஷேர் பண்ணுறோம் சார் ஃபார் அவனோட அப்கமிங் ரெஃபரன்ஸுக்காக. ப்ளஸ் அது போக எண்ட் ஆஃப் தி டுடே செஷனில் உங்களோட டாக்குமெண்ட் மட்டும் எனக்கு பிடிஎஃபாக சென்ட் பண்ணிடுங்க. நான் அப்படியே அந்த குரூப்பில் போஸ்ட் பண்ணிடுறேன் சார். அவன் எடுத்து சேவ் பண்ணிக்குவான்.
ஓகே.
தட்ஸ் ஆல் சார். அவ்வளோதான் சார். ஸோ ஸ்டூடெண்ட்ஸ் வந்துகிட்டு இருக்காங்க. நம்ம நீங்கள் சரியாக இருக்கும் சார் டைம். நீங்கள் ஸ்டார்ட் பண்ணிக்கோங்க சார்.
அப்ராக்சிமேட்டாக ஸ்டூடெண்ட்ஸ் வரும்போது ஸ்டார்ட் பண்ணலாம் சார். when week starts சார்?
நோ சார், நம்ம ஆல்ரெடி ரெக்கார்டிங்கில் இருக்கோம். டோட்டலாக ஒரு 15 இந்த ரேஞ்சில் தான் வருவாங்க சார். நான் அப்படியே ஒன் பை ஒன்னாக உள்ளே வந்துடுவானுங்க, ஆட் பண்ணிடுறேங்க சார்.
15 சார்?
எஸ் சார்.
ஓகே.
நீங்கள் ஸ்டார்ட் பண்ணிக்கோங்க சார். ஸ்டூடெண்ட்ஸ் உங்களுக்கு எதனா டவுட் இருந்ததுன்னா சார் கிட்ட கேட்கணும், சரியா? ஓகே சார், கேரி ஆன்.
Okay.
தேங்க்யூ சார், தேங்க்யூ.
Yeah, good afternoon to all. Myself, Gokul Deepan. I'm working as a assistant professor in EASA College of Engineering and Technology. So today I'm going to handle for you transportation engineering. Okay. So we will wait for 5 minutes, another 5 minutes, because sir is told nearly 15 students count. Okay. So we can start within few minutes. Okay, my voice is clear for you all. The voice is audible, pa?
Yes, sir. Clear, sir.
Yeah, okay. So the document is viewable for you. You are able to see the document.
Yes, sir, it is visible.
Yeah, it's visible. Good. So today's section is transportation engineering, and first of all, I show the syllabus. What's for our transportation engineering in view of GATE. Okay. This is your 2022 GATE syllabus, particular for transportation engineering. Okay. So they have split into two topics, main topics. One thing is transportation infrastructure, and another one thing is traffic engineering. In that transportation infrastructure, the topics are geometric design of highways, cross-sectional elements, beyond based upon the geometric design. This topics everything based related to the geometric design. Okay. So and following that, the attached the same are related to airport and airport engineering also. Okay. So and for next thing is highway pavement materials. So in here they totally discuss about the syllabus has discussed about highway materials. What are the material we are going to use? How we construct the rigid pavement and flexible pavement. I think you have aware about the pavements. There are two types of pavements is there. One thing is rigid and another one thing is flexible. So how we can construct and what is the design factors? Okay. Most of the students will done it in your semester exams also too. Okay. So and final topic is traffic engineering. So this is a full and full based upon the theory point of view. What is the traffic signs, signals, how we can measure and related to it. Okay. So when we enter to the detail section, you can able to understand how it's carried. Okay. So it is one of a easy mock dating area. Okay, because nearly 10 marks they can ask. I lost gate exam. They asking nearly 10 marks in this transportation area. Whether you can spend time of analysis or design DRCA. Okay, like comparatively that paper, which I think very easy for all. There once you prepare you can feel okay, you are comfortable with your 10 marks. Okay. So, from your syllabus, the first topic is a geometric design of highways. Okay. In the directly before we are going to the topic, we need to know some introduction about this. This is not included in your syllabus, but sometimes they can ask. Okay, because the dates are very important for us. Okay? For 1 mark, they definitely they can ask some questions like this. Uh, After the exam, we can't able to say this is not in syllabus, but they can ask how we can write not like that. Okay, because it's in your gate exam, they can ask in any way. They did not include this topics in your syllabus, but it's very important one. So I find some of the important dates for your reference. Okay, so kindly note it. It can useful for you. Okay. So this is when your first thing is JICA committee. Okay. After the First World War, the British government who rule in our country, they feel the road development is not that much good in our country. So they decide to make it in a proper way. So they appoint one committee to discuss or to take some decision to improve the road development in India. Okay, the committee was formed in 1927. The leader is Jaikar. Okay, he is a head of. They appoint Jaikar as a head for the committee. In 1928, he gives a report and he gives some recommendations. Okay. Based on the recommendation, the decision will be taken in following days. Okay. So it's understandable. You can able to understand. Yes, students.
Yes, sir. Yes, sir.
If you feel any communication issue,
No, sir. It's good,
okay.
sir.
Okay. So in 1928, they submitted a report and they give the recommendation. What is its recommended means for any road development in our country means it should be in all the interest, which means both central and state and local bodies also. Okay, this is his first recommend. And second recommendation is if you want to develop the road, we need a fund for that. We did not have enough fund to develop the road or construction the road, new road or maintaining the roads or like that. Okay, so that is the second issue. And third issue is there is no standard specifications. Okay, they did not have any standard values or standard document. Now we have that IRC code like that now. So we in previous days we did not have like that. So we need to some researchers and like that. Okay, so these are the some recommendations given by the JICAR. After that, in the following days, some process will be done based upon that based upon his recommendation. Okay. And this first thing is road development as a national interest. Okay. The British rule, open statement is given by them, that is road development as a national interest. And second thing is Central Road Fund, CRF. Okay, you maybe please keep it in your mind and kindly note this year. Okay, it is 1929. Central Road Fund was introduced, and in JICAR recommendation also he gave that idea. He gave that idea. What this means, we can collect that tax from the road users. Okay, who are using the road. Okay, we can collect taxes from them. So based upon the petrol vehicles, which are the petrol vehicles we are using, we can collect tax from them. Okay. In that time, in 1929, they collected 2 rupees 64 paise per liter. At present, it increased to 3.5, 3 rupees 5 paise per liter. Okay. In that amount will be divided into two thing. One thing is 20%, another one thing is 80%. In the total 100% amount, they divided into two. One thing is 20 and another one thing is 80. Okay. That 20 percentage is taken by the central government. Okay. For central government for that group development and some ANHI, some instructions for conducting meeting for that purpose. Remaining 80% given to the state government, okay, for the local road development, okay. Nama other district road, the national state highway, for like that, okay, we can develop the road by using that 80% of amount. Okay. So this is the done on Central Road Fund, okay. And next thing was Indian Road Congress, IRC. So this formed in 1934. It's formed
Sir,
in 19. Yeah.
sir, there was Nagpur Road Plan also in 1943.
Nagpur Road Plan in 1943. Yeah, okay. You can add that to that also. Okay. This is
Okay,
comes after the we can take a tell it
okay,
is
sir, fine.
20 years plan. I think. Am I right? Comes under your
Yes, sir, yes.
yes, yes. Okay, I think it may be in continue. If I miss means kindly note it. Okay, because all the years are important. Okay, I will take which is very important. If something I missed means you can also keep it in your mind. If you have anything else, just you can tell. It is used for your friends also. Okay.
Okay, sir, you can carry on.
Yeah. Okay, so IRC in 1934, they give the standard specifications. So now we are using IRC code books. Okay, so for your rigid payment and flexible payment, we have a separate code books, Indian standard code books. That everything was given by the IRC, Indian Road Congress. Okay, so it's introduced in 1934. And next thing is Central Road Research Institute. It started in 1950. Okay, so those are the important recommendations done by the JICA committee. So it's very important. Keep in mind the above mentioned dates. And second, next thing was Motor Vehicle Act in 1939. It revised in 1988 and came into force in 1989. Okay, sir, in your question, okay, in your question, if they given the both the 1988 or 1989 or 1939 as an option, option A 1939, option B 1988, option C 1989 means which answer we want to give. Okay, we can have some like the doubt also. In that time, you can give the what is the present thing. Okay, so you can go with 1989. Okay, so this is introduced to regulate the traffic rules. Okay. So now, which side we want to take and which side we need to overtake the vehicle and what are the signs, what is the signals, everything will disclose in Motor Vehicle Act. Okay. So, next important here is National Highway Act in 1956, the responsibility of development of maintenance of national highway like with central government. Okay, so this is comes here in second road development plan in 1961 to 1981. So this is we can call it as also Bombay Road Development Plan. Okay, yeah, the target, this main thing, these questions also they can ask, what is the target in second road development plan or what is the target in Bombay Road Development Plan? Like that means the answer is 32 kilometer per square kilometer. Okay, this is the answer for that question. And the next thing was another important one thing was Highway Research Board of IRC 1973. Okay, this is we can take it as a the third 20-year plan. This is 1081 to 2001. We can take it as a Lucknow plan. Okay. That target is 82 kilometer per 100 square kilometer. Just you can compare with the above mentioned and those. Here this is 32 kilometer per 100 square kilometer, but here 82 kilometer per 100 square kilometer. So it's developed because we get that much of new equipments and new technologies we can get. Based on this, we can able to achieve this 82 kilometer per 100 square kilometer. So those are some important dates, and you were saying told that is Nagpur Road Development Plan in 1943. So you can keep it in your mind and that also. Okay. And the next topic is pavement surface characteristics. And what are the surface characteristics in pavement? Is first thing is friction. You have an aware about it, the friction between the road and your vehicle. Okay, so that is where first thing is your friction, and another one thing is unevenness. So it means some undulations, the road roughness. Okay, that is comes under your unevenness. And third thing is light reflection characteristics. So you can see some yellow sticker you can see in your road. In night time it is glitter. Okay, so like that's the thing that is light reflecting characters. And next thing is drainage of surface water. That is, we can take it as a camber. The camber is provide for surface water. Okay, where the water is into the your road surface, it need to drain out. Okay, so we need to provide the camber. So in the following things we are going to discuss. So this is what are the factors affecting the friction. First thing is a condition of payment, and next one is condition of tires, and third is speed. Okay, this is over speed also is one of the important factors. Friction and extent of brake application, and load and tire pressure, and last one is temperature of pavement. Okay, here that is not important, but what I mentioned in blue pen. Okay, this is very important. So keeping on your mind, the longitudinal friction coefficient is 0.35 to 0.40. The lateral friction of coefficient is 0.15. Okay, this is kindly note this point. It's very important, because in following slides you are going to see stopping side distance problem, super elevation problem, transition curve problem. In all the places you are going to see these values. Okay, the longitudinal friction of coefficient is 0.35 to 0.40. Lateral of friction coefficient is 0.15. You can note. Are you noted? Yes, students, is audible.
Yes, sir.
Yeah, you can give some answers. Okay. The otherwise, I feel that class is uh, some sound
Okay,
issues
sir.
like that. Okay. So, are you noted?
Yes, sir. Yeah, you are noted. Sir, you will share this PPT afterwards also now.
Okay, fine. So the next thing is payment unevenness. Payment unevenness is nothing but a cumulative measure of vertical undulations of the pavement surface recorded per unit length. Okay, the cumulative measures of vertical undulations. Okay, this is shown the diagram like this. Those undulations. Okay, so the and when in here in green ink I will mention one thing, that is value of unevenness index and type of payment. Okay, so this is if it is less than 1500 means mm per kilometer means kilometer per kilometer means is a good, and 2500 mm per kilometer means it is a certification. It is 3000 mm per kilometer means it is not good. Okay, so this is payment annulation, and this area is also important. So you can, when we get the notes, we will check it out, check it this one. And next thing was light reflecting characters. Already I told, you can see about that. In night time, you can be able to see that, I think so. And there is in your rigid payment, it is a yellow marking. In your flexible payment, is white marking. Okay. You can take this. So now this marking is not developed into a with sticker systems. Okay, we have a separate name for that. So this can also ask what is the rigid payment, what color marking is there. It may be blue, so some color they may be blue. The answer is yellow. For flexible payment, it is white marking. Okay. And next thing is I will told the drainage, surface drainage. And this is camber or crosscut, we can call it as like this. So it's a straight line. It have three classification. One thing is straight line camber, and another thing is parabolic camber, and third thing is combination straight line and parabolic camber. There are three types of them. So it is we provide camber to drain out the water from the road surface. Okay, for that purpose only we are providing the camber in the road. You all able to see when when you are using the road, you can see they can provide a slope on one side or they can provide in like this in the diagram. Okay, they raise the height in center of the road. Okay, and the next thing is this is the relation. So from this, from here onwards, we are entered to our syllabus. Okay, from the fiction. Okay. From here onwards, we can payment satisfactory. From here onwards, we are entered to the syllabus. Okay, so keep in your mind. Okay. Relation between longitudinal gradient and camber. What is the relation between longitudinal gradient and camber? The answer is G equal to 2C. That is nothing but for a better drainage and smooth flow of traffic, the camber of the road should be approximately equal to half of the longitudinal gradient. Okay. So when this is 2 is come here, this is G by 2 equal to C. Your camber is equal to the half of the longitudinal gradient. Okay. So this is the relationship between longitudinal gradient and camber. So this is very important. Then keep this also. Sometimes the one more question they can ask this thing. So you can take this. And recommended value for camber for different types of road surface. So what are the values we can provide? Okay. So the first thing is cement concrete road. If you are cement concrete and the high type means you can range of camber in areas. It may be in heavy means you can provide 1 in 50. If it is light means 1 in 60. This is based on rainfall range. Okay. If there is heavy rainfall means you can provide 1 in 50. That is 2%. And if it is uh, rainfall is not that much means in that area you can provide 1 in 60. Okay, and the thin bitumen surface, in thin bitumen surface you can provide in our road we are which the roads we are using now in 40 2.5 percentage and 1 in 50. If it is light, 1 in 50 is enough, that is 2% is enough. In weather-bound macadam, WBM, this kind of road will not have any top layer, just we can have the soil, gravel, and combination of that. In that kind of road, we can provide a camber up to 3%, 1 in 33. If it is light means you can provide 1 in 40, that is 2.5%. If it is a 10 road, you can provide in 1 in 25, that is 4%. If it is light means 1 in 33, it is 3%. So next thing is width of pavement or carriageway. So this is the maximum width of vehicle as per IRC is 2.44 mm. I think this question is asked in 2018 or 2017. In one gate exam, they are asking this question: what is the maximum width of vehicle as per IRC standard? That is 2.44 mm. Okay. The number of lanes depends. So how many lanes we are going to provide? Okay, it is depends upon two things. One thing is predicted traffic volume and traffic capacity of each lane. Okay, so those two things is important. Based upon the thing, we can provide the lanes. Okay, number of lanes. So its carriageway is nothing but this is how much we provide the space for movement of vehicle. So that comes under your carriageway. Okay. And this is first thing is a single lane. It's if your road is a single lane road means you have to provide a carriageway is
Sir,
3.75 meter. Yes.
sir, your voice is breaking, sir.
Just a minute, I will check. Now it's clear.
Yes, sir, it is clear.
Okay. So if your road is a single lane, it is a single lane road means the width of carriageway is 3.5 meter. If it is two lane road means without raised curve, it is 7 meter. 2-lane roads with a raised curb. If you are providing the curb means it is 7.5 meters, and intermediate carriageway. This intermediate carriageway means which is 5.5. Multi-lane payment means 3.5 per lane. For example, if your road is a 3-lane means its total carriageway is 10.5 meter. Okay, it is 10.5 meter. And now this, the width of pavement is increased on the horizontal curve to take care of tracking and psychological effect. Okay. The width of pavement is increased on horizontal curve. Where will you see the horizontal curves are there? In that area, the width of pavement is increased. Okay, little bit it will increase because when the vehicle is turned, it needs some space. So take care of tracking and psychological effect also. When we suddenly see some curve means suddenly we have some we get that reflection on our mind, so it takes some time to take some decision. So that road length, that the road pavement width will increase. Okay.
Sir,
Yes.
sir, is there any specific dimension for the width of the road, sir, in the turnings?
Yeah, it is based on extra widening of curve. Okay. In following section, we are going to learn about super elevation. It is hint for super elevation. Okay. In following classes, so not following slides, we are going to see the super elevation. When you get when you understand that means it is you can easily get answer for this.
Okay, sir.
Okay. And next thing was traffic separator or medians. Okay, so traffic separator or medians, it's provided to prevent head-on collision. Okay, if it is provided to avoid the accidents. Okay, IRC recommends a minimum desirable width is 5 meter for medians of rural highways. In rural highways, IRC recommended 5 meter. Okay, on long bridges, it may be up to 1.2 meter. Okay, this is for a traffic separators or medians. Okay. And next thing is road margin. Yeah, you are all aware with that because you can definitely you will see this. Okay, this is road margin. The minimum shoulder we can say in road margin we need to discuss 3 topics. One thing is shoulder, another one thing is frontage road, and third thing is driveways. Okay. So in this first thing is shoulder, the minimum shoulder width recommended by the IRC is 2.5 meter. So say emergency lane. Okay. So the total carriageway is there. Apart from that carriageway, uh, a separate width, the road is increased. Yes, one lane is marked. Apart from that is 2.5 meter space is given. Okay. Serve as a emergency lane. Also act as a service lane for vehicles. Okay. We have that service roads and that all. It's everything comes under your shoulder. And second thing was frontage roads are provided to give access to properties along an important highway with controlled access as expressway or freeway. Maximum the heavy tonnage vehicles, the heavy load vehicles will use this way. That is called front tonnage road. And next thing is driveways connect the highway with the commercial establishment like fuel station, service station, etc. This is called as driveways. Okay. And next thing is width of road or formation. How the formation of width is taken. So once you see this formula, you can get some idea. Okay? So this is formation is carriageway width plus shoulders. Okay, carriageway width including separators. Okay, plus shoulders. So this is the formation of formation width. Okay? The carriageway is minimum 3.5, including this 2.5. Okay, the total road formation width is 3.5 plus 2.5. What is total formation width? Already I told the carriageway. What is the carriageway width? I think you can have it. It is if it is multiple payment or
2.5.
Single lane means 3.75 or a 2-lane means 7.5 or multiple payment means 3.5 per lane. You can take 3.5 per lane. Okay, you can keep it in your mind. Okay, and if it is 3.5,
Sir,
Yeah.
Sir, it means when we double the lanes, its width gets increased.
Without, pardon?
Width of carriageway gets increased only when lanes are increased, sir.
No, no, no. The width of pavement is increased on the lane. For every lane, we can provide a 3.5 carriageway. If you have 2 lane means it is 7. If you have 3 lane means it is 10 point,
Ah,
like that. Okay.
okay, fine, fine, sir, fine, fine.
Yes, that's only an example mentioned here. 3 lane, 10.5 meter. 3.5, 3.5, 3.5. It is 10.5.
Okay, sir, okay.
Yeah. So if it is like 3.5, and what is the shoulder length I mentioned here? This we can take. This shoulder is 2.5.
2.5, sir.
Yeah, good. So 3.5 plus 2.5, that is your total formation of width. Okay. So like that you have to calculate, and formation. This is some based upon your IRC standards. I mention this formation width of national and state highway. If it is your plain and rolling terrain based upon your terrain, and it is mountain and steep means how it is differentiated. If you are single lane means it is 12 meter maximum. You can provide up to 12 meter. Okay. If it is mountain or steep means maximum you can provide up to 6.25 meter. This everything is maximum, not minimum. Okay. Maximum you can provide up to 12 meter. Okay. If it is 2 line, maximum you can up to 12 meter. This is 8.80 meter. And major district road is 9 meter. Other district road is 7.5 meter. Other district road double lane is 9 meter, and your village road is 7.5 meter. These are some recommendations given in your IRC. And next thing goes right of way, area of land required for a road along its alignment. Area of land required. So we need to construct the road means we need some land for that. So total area required for making a road, it's called as right of way. The right of way is formation of width plus road margins. Okay, it is not only stop with formation of width. For it extended up to road margin. We need to some road margin also. Apart that margin only, the buildings can able to construct. Okay, before that margin, if the building is constructed means the highway department have authority to demolish that. Okay, for that only the road margin is also included here. Okay. So normal land width required for national and state highway is 45 meter. Normal land width. Okay, you can acquire yeah, for national state highway is 45 meter. It may be restricted below 45. If it is more than 45, is no needed. Okay, so that's mentioned here. And maximum land width required for national and state highway. Normally we can take out 45 meter. Maximum we can go up to 60 meter. Okay. Correspondingly, distance between building lines is 80 meter, and between the control line is 150 meter. Okay. So the distance between building lines, so from your national and state highway, right of way to building. Okay, building lines, the distance is 60 meter, and control line is 150 meter. Okay. So next thing was here you will see the area of required for road along its alignment. So we have to know what is alignment. Okay? So this is highway alignment and survey. It's another one small topic. Okay, just you can keep it. After that, we can go to following that. We will continue with geometric designs. Okay. So I mentioned that word alignment, so you have to know what is alignment. For that only I add this in between here. Okay. So highway alignment and survey. Alignment, the position or layout of the central line of the highway on the ground is called alignment. Okay. For example, you are going to construct a road. It's between Coimbatore to Chennai. Means there are different possible ways is there. Okay. In the possible ways, we have to choose one best way. Okay. That best way is called as alignment. At which point it is going to reach. For example, for Chennai, we can go with from Coimbatore to Krishnagiri, Krishnagiri to Velur to Chennai, or we can go with Coimbatore to Erode to Salem to uh, uh, Kallakurichi to Chennai, like that. Okay, so there are different alignment is there. So we can select any one alignment based upon our requirement. So what are the requirement is there? Means it is short and easy, it is safe and economical. Okay, based upon compare, you have to there is different possible route is there for any point. There is different possible route is there. Okay, in that we have to. It's our responsibility to choose which one is best or which one is good for us. Okay, so that is called as that points is called as alignment. For here, the alignment is Coimbatore to say Erode to Salem to some other place, and next to Chennai. So this is the alignment points. That is okay. So what are the basic requirements and alignments? Already I told you this. We can select the alignment based upon which is short, which is easy to construct, which is safe. Easy means here. What is the difference between short and easy? Short means it's based upon distance. Easy means whether you can find some way. It is there. It is maybe short, but between in that way you can find some river or lake or water body area or agriculture land. Means you can't able to execute your plan. Okay, it will give the obstacle to execute your idea. So it is not an easy thing. So that is the thing in easy. Okay, so which is comfortable to construct. That is easy. Okay, and next thing is safe. Okay, it's also very important. And next thing is economical. Okay, you have to compare with cost. Okay, you need to construct some bridges or some other things. Uh, in that alignment means you can avoid that. Yes, in some alignment there is no bridges at all. We can easily reach our destination. Means you can go with that one. Okay, so that is short, easy, safe, and economical. And next thing is what are the factors affecting alignment? The first thing is obligatory points, that is called as control points. Okay, which are the points we have? It have two things. One thing is should pause, should not pause. For example, if some hill is there, you can able to pass or not. You can around that hill you can construct the road. Otherwise, you can make tunneling or like that. Okay. So otherwise you can avoid that. That is, you should pass or should not pass. If it is should not pass, you have to make around the hill. You have to construct the road around the hill. For example, it is Ooty is an example for around the road. And next thing is you can tunnel. Otherwise, you can just make a tunnel. You have to uh, you can make a construction between that hill. You can use that way for your road user or a highway for like that. Okay, so that is called concern you should pass or should not pass. And second thing is traffic. If there is more number of traffic means you can go to construct the road. Okay, a new road. And then you can make a new alignment and you construct the road. And as in a geometric design, for some cases, in some traffic or some highway construction, the geometric design you can't able to applicable on that place. So based upon geometric design also, sometimes your construction will stopped. Okay, and as thing is economical based upon cost. If it is more economical means we can't able to go with that. Okay, and other consideration is drainage. Need a water draining facilities there. If it is not means there is another issue, and hydrology and political issues also something make a role. Some educational institutions, some buildings, some temples. Okay, like that place you can't able to reach that. So it also make issue on some cases and topography and for the alignment, there is engineering surveys there. What are the things we are going to see? This is map study, recognition, preliminary, and final location. In the map study, you are using the topography map. For the one I mentioned here, it is topographical map you are going to use. In modern survey, now we are using satellite images like that. Okay. In the recognition, what you are read in your topographical map, you go to the site and or you go to the construction where you are going to construct the road. In that place you have to recognize what you are see, what you are collecting, what the information you are collecting in the map, if everything is exactly in the field or not. Okay, that is comes under your recognition survey. And next thing is preliminary. After you go and set your equipments, and you can make the preliminary survey. In the recognition survey in modern times, now we are using a GPS and so other thing. And preliminary survey, you can go to a survey and final location. We use now, we have a total station and some other new things are there. We are use that for our detailed survey. And next important topics. So you can accept, you can in your exam point of view, you get some problem in this area. Okay? This is a highway geometric design. In the first thing is side distance. There are three types of side distance are considered. And first thing is SSD, that is stopping or absolute minimum side distance. And second one is OSD, safe overtaking or crossing side distance. And third thing is ISD, that is intermediate side distance. So there are three different types of side distance are there. This first thing is stopping side distance. Stopping side distance is nothing but when you are driving your vehicle. Okay, just you can when you are operate your vehicle, suddenly you will get some obstacles. Suddenly you can see some obstacle in front of you, means you need some time to stop your vehicle. Okay, so before constructing the road, we need to think in our mind. Okay, so that is called as stopping side distance. So after seeing the your obstacle, how you need some time to take some decision. So you plan according to that on your road construction. Okay, the distance between a moving vehicle with the high level of the driver at the height of 1.2 meter and the object of 0.15 meter, so that no collision occurs in case of situation arise to stop a vehicle. Okay, if a driver weight, okay, if a driver high level is height is 1.2 meter and the object is 0.115 meter, means he can able to see the collision or he can able to see the obstacle, so he can avoid the collision. Okay, so this is thing. So total reaction time, when you see the obstacle, there is some reaction time is there, that is total reaction time, that is prescription time plus break reaction time. Okay, that is prescription time plus break reaction time. So that is the total reaction time we can split into four types. One thing is prescription, and another one thing is intellection, and third one is emotion, and fourth one is volition. Okay, so this is we can call it as a PAEV theory. Okay, this is we can call it as a PAEV theory. This total reaction time. Okay? This total reaction time we can split into four types. That is here. That is perception, intellection, and emotion, and after is violation. So the total reaction time is 2.5 seconds is considered satisfactory for most situations. So here you can take it as a T. Okay, the total reaction time T is 2.5 seconds is considered. Okay, the total reaction time is 2.5 seconds is considered. The distance traveled by vehicle, total reaction time is known as lag distance. Okay, after seeing your obstacle, a particular distance your vehicle is traveled, that is called as a lag distance or reaction distance. Okay. The distance traveled after application of brake into its stop position is known as brake distance. After applicable your brake, also the vehicle is have a little bit forward movement, that is called as braking distance. Okay. So now the formulation of a stopping side distance equation, SSD equal to lag distance plus braking distance. That is stopping side distance equal to lag distance plus braking distance. There is some derivation is there, but it is not that much important in your gate exam point of view. So I directly quoted here the formulas. Okay. So it is enough when you keep these formulas in your mind. Before going to the exam, just you can go through it. It's enough. Okay. The formula is SSD equal to 0.278 V into T plus V square divided by 254 M. Here the V stand for speed and T is reaction time and F is friction. Okay. If it is your kilometer per hour means you have to use this formula. If it is meter per second means you have to use this formula. You can use anything. Depends upon your question. And after can also you can convert it into your kilometer per hour, meter per second. Okay. That is SSD equal to VT plus V square divided by 2GF. You know, I think you are aware about this. V is here mentioned for your speed. Okay. So we can see some, I have one or two problems we can see. After we can move to the next topic, that is this is if it is slope, means you have to use this formula. If it is ascending gradient or descending gradient is there. This is mentioned here, plus or minus. Okay, so that is SSD equal to 0.278 VT plus V square divided by 254 F plus or minus 0.01 N. This N stands for gradient, N percentage. It is a, in your question they mentioned 2%, 3% like that. Okay. So this is N is stand for gradient percentage. Okay. So this is if you are using for ascending gradient, you have to use the positive sign. This is plus or minus is there. Positive sign. If it is descending gradient, you have to use the negative symbol. Okay. And another one thing is if you calculating for single line means you can directly get the answer. What is your SSD answer? That is the answer. If it is the double line or the two line means you have to take 2 into SSD. Okay. So you can go into problems. So I think we will take, okay. Calculate the, here this is your problem. Calculate the safe sighting, calculate the safe stopping sight distance on the level road stretch of design speed of 50 kilometers for a two-way traffic on two-lane road, two-way traffic on single-lane road. Okay. There are they give two options also. You have to solve this also. So first thing is already I told what is the V stand for design speed. So you have to write 50 kilometer per hour. If they mentioned in question means if they mentioned the time T is mentioned means you can take that. If it is not means it is 2.5 seconds. Already I will we will discuss here. The total reaction time is 2.5 seconds. Okay, so this is here, and I already asked you to noted one thing, that is friction. Yeah, this is. So longitudinal friction coefficient is 0.35 to 0.40. If they mentioned in question, you can go with that. If it is not, you can take the value between 0.35 to 3.0.40. Okay. So they take here it's 0.37. So F is 0.37, T is 2.5. The speed is 50 kilometer per hour. So we have all the data directly. We can substitute that in this formula. The SSD formula is 0.278 VT plus V square divided by 254 F. Okay. So the answer is 0.27 into 50 into 2.5, and the speed is 50. So you can where you see in the formula you substitute 50 for speed. 2.5 50 square divided by 254 into 0.34. The answer is 61.4 meter. Okay. When there is there are two lane means you can take that is if it is single way traffic. Okay. In the question they are mentioned two-way traffic on two-lane road, two-way traffic on single lane. Two-way traffic on single lane this is 61.4 meter. On single road with the two-way traffic means you have to multiply your answer with 2. That is 122.8 meter. You have any doubt on this problem? You have any doubt? You have any doubt? Is it audible?
Sir, you can present, sir. Others are taking notes only, sir.
Okay.
Yes, sir.
So this is now I think we will come with another problem, that is calculate the stopping side distance on highway at a descending gradient of 2% for a design speed of 80 km per hour. Assume other data as per IRC recommendations. Okay. There are in the question they mentioned IRC recommendations. They ask you to assume. So as usual, you can take your total reaction time, that is t equal to 2.5 second, f equal to 0.35. This is a descending gradient. So it is slope based problem. Okay. So they mentioned in question 2%. Okay. Yeah. You are seeing here. It is 2%. And they mentioned here in question that is descending gradient. If it is descending gradient means you have to take minus. Okay. So here the formula is SSD equal to Vt plus V square divided by 2G into F plus or minus N percentage. Okay. So if your speed is, what is your speed? 80 kilometer per hour. So they can convert here into meter per second, that is 22.2 meter per second. So you can take, that is 22.2. Here the mistake is there. There is 22.2 into 2.5. 22.2 whole square divided by 2 divided by 9.8 into 0.35 minus 0.02. Okay, because it is descending gradient. So you will get the answer. This is 132 meter. Otherwise, you can go with this formula. Okay, here is the LD equal to 0.278 Vt plus V square divided by 254. Okay, F plus or minus 0.01 N. So here what we can write equal to 0.278 into directly speed on the 80 into t is 2.5 plus V square, that is 80 square divided by 254 into F is 0.35 minus 0.01 into 0.02, means you will get the answer, same answer, 132 meter. Okay, you can use any one formula. Later you can convert it into kilometer per hour or meter per second. So this is based upon your stopping side distance. Next thing is overtaking side distance. So overtaking side distance is when you are seeing one vehicle is overtake another vehicle. Okay, so they need some minimum side distance to take some decision. Okay, so we need to provide that thing also before constructing the road. We need to keep that thing also in our mind. Okay, the minimum distance open to vision of a driver of a vehicle intending to overtake slow vehicle ahead with safety against. The traffic of opposite direction is known as minimum overtaking side distance or safe crossing side distance. Okay. As per IRC standard, okay, the distance measured along the central line of road which a driver with this high level at 1.2 meter, already I told is 1.2 meter, above the road surface can see the top of an object 1.2 meter above the road surface. Okay, and what is the formulation of OSD? So it is have three things is there. One thing is D1, another thing is D2, another one thing is D3. D1, D2, D3, and D1 is nothing but here. Distance traveled by overtaking vehicle A during the reaction time of T from the position A1 to A2. So this is from the position of A1 to A2. This is comes under your D1. And D2 distance traveled by the vehicle A from the A2 to A3. A2 to A3. Okay. So here from the here is A2 is here and A3 is here. Okay. So the A1 first D1 is the vehicle is travel A vehicle is travel from travel between A1 to A2. That is your D1. This A2 to A3, that is your D2. And distance travel on coming vehicle C from C1 to C2 during overtaking operation. During overtaking operation, in the another lane also some vehicles can also that is possible to come. Okay, that is C1 to C2. This is C1, C2. Okay, so that is comes under your D3. Okay, so this is for overtaking side distance we have to calculate D1, D2, and D3. So the D1 formula is VB dot P. That is this VB is they are mentioned for slow moving vehicle. Okay. D2 is VB dot T. This T is time time taken to overtake, that is 2 seconds. If nothing is mentioned in question paper means you have to take directly 2 seconds. If it is capital T is total time taken. So for this full operation, total time taken from A1 to A3. Okay, this total time taken is mentioned in capital T. Okay, VB dot T plus 2S 2S. Okay, this T we can calculate by using this formula, that is root of 4S divided by A. And for S you have to calculate for S, you have to calculate by using this formula. If it is space between vehicle, if it is meter per second means 0.7 VB plus 1. If it is kilometer per hour means 0.2 VB plus 1. This is, you know, the VB is slow moving vehicle. This V is fast moving vehicle, T3. V dot T. This is called as fast moving vehicle. Okay. So when you see the problem, you can able to understand. Okay. So overtaking side distance equal to in kilometer per hour. This is D1 plus D2 plus D3. That is 0.278 VB dot T, 0.278 VB dot capital T, plus 2S plus 0.278 VT. Here I mentioned in meter per second. Here I mentioned in kilometer per hour. Okay, in the same place I differentiate the two things. Okay, so I don't want to repeat. So I mentioned here itself. Okay, so now you can see the problem based upon the overtaking side distance. For one-way traffic, overtaking side distance is D1, D2 plus D3. For two-way traffic, for one-way traffic, the overtaking side distance D1 plus D2. You can see the problem based upon the overtaking side distance. The speed of overtaking and overtaken vehicle are 70 and 40 km per hour respectively. On a two-way traffic road, the average acceleration during the overtaking may be assumed as 0.09 meter per second. Calculate the safe overtaking side distance. What is the minimum length of overtaking zone? Draw the sketch of overtaking zone and show the question of the time course. Okay, so in this question you can see all the things. Okay. So what is the overtaking vehicle is 70 kilometer per hour, or a overtaken vehicle is 40 kilometer per hour. So this is slow moving vehicle is 40 kilometer per hour, which is fast moving vehicle is 70 kilometer per hour. So you have to take, that is VB is 40 kilometer per hour, V is 70 kilometer per hour. They are converted into meter per second. So directly your speed is divided by 3.6. So it is comes to 19.4, and your slow moving vehicle speed is 11.1 meter per second. So this is overtaking side distance OSD equal to D1, D2 plus D3. Your D1 formula is VB dot T. So VB into T. VB is your slow moving vehicle speed is 11.1. Okay, 11.1 into T is 2 seconds. So you will get 22.2 meters. And D2 is VB dot T into 2S. Okay. So the formula for S is 0.7 VB plus 6. So 0.7 into 11.1 plus 6 is equal to 13.8. So X value is 13.8. Your T value is T equal to root of 4X divided by A. There is 4 into 13.8 in acceleration. In the question, the acceleration given is 0.99 meters per second. So 0.99 is your t value is 7.47 second. So finally, your d2 is 11.1 into 7.47. That is nothing but your slow VB into your t. That is 7.47 plus 2 into s 13.8. The answer is 110.5 meter. If it is d3 VT equal to 19.4 into 7. This is V is fast moving vehicle. So that value is fast moving vehicle value is 19.4 and capital T already you are calculated that is 4.7.47. The value is 144.9 meter. So total overtaking side distance is D1 plus D2 plus D3. That is 22.2 plus 110.5 plus 144.9 meter. The total answer is 277.6. You can take it into nearly 278. Okay. If it is, and another one thing is asked in your question, what is the minimum length of overtaking zone? So first thing is calculate the overtaking side distance. You are calculated that what is the minimum length? Okay. So minimum length of overtaking zone is nothing but 3 into overtaking side distance. What you are getting? Okay. So 3 into OSD it is 834. And next thing is desirable length of overtaking is nothing but 5 into OSD. What your answer get into 5. So 5 into 278 it is 1390. So and C1 is that they ask you to draw the diagram. Okay. So like that you have to draw. You have to draw like this. This is a over thing. This is 278. This is 834 to 132. This is your vehicle is 278. So your vehicle speed is 278 meter. Okay. So this is comes under your SP1 is sign post for overtaking sign height. SP2 is end of overtaking zone. This is your end of overtaking zone. Okay. So like that same the question 2 is there called like the safe overtaking by distance for a design a speed of 96 km per hour and assume the all other data suitably. Okay. Based upon your problem 1, you can solve the problem 2. When you get this material to your hand, you can try this second problem. Okay. Okay. If you have any doubt or means in the section name, I will give my ID, mail ID. You can contact me through that. You can try to solve the second problem in overtaking side distance. And next topic is geometric design for a vertical alignment. Okay. It's for a vertical alignment. So vertical alignment is nothing but it's a longitudinal gradient. Okay. So gradient is the rate of rise or fall along the length of road with respect to horizontal express as vertical and horizontal unit. Okay. So it is gradient. It's a rate of rise or fall along the length of road. So you can see in your highway there is you can feel it is not in a same. If there is a one rise is there, another there is a fall is there, another again one rise is there. That is okay. So that is we can call it as a geometric that is called as a gradient. Okay. If it is vertical means it is mentioned in I. If it is horizontal means it is mentioned in yes. There are three types of gradient is there. One thing is ruling, and another one is limiting, and another one is minimum or exponential gradient. Okay, there are three types of gradient is there. Based upon the different terrains, the gradients also values also change. Okay, if it's also now the important thing they may ask in your one more question. If it is a plain or a rolling terrain, if it is plain or a rolling terrain, your ruling gradient, okay, what is your ruling gradient is 3.3%. If it is your ruling gradient is 3.3%. If it is same thing for your plain or rolling, if your limiting gradient is 5%, that is 1 in 30, 1 in 20, and your expression gradient is 6.7%, that is 1 in 50. If it is mountain or steep, it is 5%. and if it is your limiting gradient is 6%, your exponential gradient is 7%. Okay. If it is steep terrain, your ruling gradient is 6%, and your limiting gradient is 7%, and your exponential gradient is 8%. Okay. And the next thing is your grade compensation. That is the important one. Okay, your grade compensation is as per IRC standard. The grade compensation is not necessary for gradient flatter than 4%. If your gradient is flatter than 4% means there is no need to provide grade compensation. So it is very, very, very important thing. They may ask, okay, what is the grade comp? What is the in at what percentage we need no need to consider grade compensation means the answer is 4%. So for finding the grade compensation or for providing the grade compensation, the formula is 30 minus R, okay, or 75 divided by R, okay. This is R is stand for radius, 30 minus R divided by R, or 75 divided by R. The R is stand for radius. The derivation is there, but it is not important for you because in your gate exam they are asking only problems, not derivations. So keep this formulas in your mind. Okay. If you know the formulas, means it's very easy to solve any kind of problem in highway engineering or transportation engineering because all the questions are in direct only. Nothing is indirect. So next thing is highway geometric design on horizontal curves. Okay. In a previous topic, when I take on a curve, someone is asked if there is any specific value is there for that. Okay, that is called yeah, it is there. It is we can call this a super elevation. Even your horizontal curve, when we operate some vehicle, where you are find some curve means when you drive your vehicle on the curve means uh, you some extra force will you will feel that is called a centrifugal force will act on your vehicle. Okay, due to the centrifugal force, your vehicle may get trouble, okay, or it may be make in a fall condition also. For avoiding that, we need to increase our inner edge with respect to the outer edge. Okay, so that increase height we can call it as a super elevation. Okay, we can call it as cont or banking. So we have some other names is also there, that is called or banking. So the super elevation is nothing but rising of outer edge of pavement with respect to the inner edge. Your outer when you operate the vehicle, the centrifugal force will when you operate the vehicle in a curve, horizontal curve, the centrifugal force will act on our vehicle to counteract that force. We need to provide we need to increase the outer edge of the pavement with respect to the inner edge. Okay, wow. So that is called as super elevation or transverse slope, and also called as a cont or banking. The equation of the general equation from the derivation we will get, the general equation is E plus F equal to V square divided by GR. Here the E stand for super elevation, E stand for super elevation, F stand for friction, V stand for speed, G stand for gravitational force, and R stand for radius. So once you need the value of super elevation means E equal to V square divided by GR minus F, that is friction. Okay. On your horizontal curve, the friction is you can take your F value is nearer to 0.15. Okay. Okay, in your according to your equilibrium super elevation, that is in your equilibrium super elevation, F equal to 0. The formula is E equal to V square divided by 127 R. Okay, you are using in your problem this formula, that is E equal to V square divided by 127 R. Otherwise, mixed traffic, it is 75% design speed means the formula is equal to 225 R in kilometer per hour. Okay, that's everything. Okay, and the in previous topic, one person is asked if there is any standard is there. Means yes, the standard is there. You have to provide maximum super elevation up to 0.07. Okay, in hill roads 0.1. The super elevation is not more than 0.07. We have to provide up to 0.07. You can raise the outer edge. Okay, you can raise the outer edge up to 0.07 tab. Okay, not more than that. So we can see the formula. Sorry, we can see the problems for super elevation. So steps for super elevation. So there is nearly you have steps are there, and first thing is super elevation is calculated for 78% of design speed. That is 0.75 meters per second, 0.75 kilometer per hour. Means you have to neglect the friction. That is equal to 0.75 V whole square divided by GR, or the formula is 0.75 V square divided by 127 R. If it is you are equal to kilometer per hour, means equal to meter per second or equal to kilometer per second. If it is more than 75%, okay, calculator up to 75% means you have to use that formula. If it is more than 75% means you have to use E equal to V square divided by 225 R. That is your design speed is more than 75 means you have to use E equal to V square divided by 225 R. V stand for speed and R stand for radius. These two formulas we can use. If calculated E is less than 7% or 0.07, the value so obtained is provided. Okay, the E is less than 7% or that is 0.07. Okay. If the value E extended to 0.07, then provide maximum super elevation is 0. If you are calculating super elevation, if you get your value is 0.10 or 0.10 or 0.9 or 0.12, like that means you have to restrict that value to 0.07. And your next step is check the coefficient of friction developed for maximum value of equal to 0.07 at full value of design speed is 12 meter per second, or you can take it every speed in kilometer per hour also. That is f equal to f equal to v square divided by gr minus 0.07. So the friction is f equal to v square divided by 127 r minus 0.07. That is super elevation value, E order value. If value of F is calculated less than 0.15, the super elevation of 0.07 is safe for design speed. So you can take friction as for a super elevation problem. Friction F is 0.15 and super elevation E is 0.07. And this is where safe allowable speed. The formula for a safe allowable speed is V equal to root of 27.94 R. This is your problem. The design speed of highway is 80 km per hour. The horizontal curve of radius is 200 meter on a certain locality. F equal to 0.15. Calculate, you have to calculate the super elevation. If the maximum super elevation of 0.07 is not to be exceeded, calculate the maximum allowable speed on horizontal curve. Okay, they ask you to calculate two things. Okay, and they give what is the speed, that is 80 km per hour, and they give the R radius, that is 200, and in the question they give friction also, F equal to 0.0. Super elevation required for 70% of design speed. Okay, that is 0.75 km per hour. Okay. That is E equal to V square divided by 225 R. So your speed is 80. So you have to note that 80 in the place of in the position of V. That is 80 square divided by 225 into 200. Your answer is 0.142. This value is greater than 0.07. So you have to restrict that value into 0.07. So the maximum super elevation is E equal to 0.07. Whatever value you are get in your exam for super elevation value means you have to restrict that value to 0.07. Please keep this in your mind. Okay, and check off next they ask you to conduct they ask you to find coefficient of friction, that is F equal to V square divided by 127 or minus 0.07. That is 80 square divided by 127 into 200 minus 0.07. The answer is 0.18. Okay. So as 0.18 is greater than 0.15, the maximum allowable friction is 0.15. So you have to restrict that into the same. Okay. Maximum allowable speed VA equal to, the formula is VA equal to root of 27.94 R. Okay. So VA equal to 27.94 into 127. The answer is 74.75 kilometer per hour. So the maximum allowable speed is 74.75 kilometer per hour. So next question is design the rate of super elevation for horizontal curve of radius 500 meter and speed 100 kilometer per hour. Okay, here step 1 is E equal to V square divided by 225 R, that is the speed is 100. So you directly mention you will get 0.089. So the answer is 0.07. Okay. So you will get 0.089 is the answer. So you have to restrict it into restricted that value to 0.07. The super elevation is 0.07. And third next step is you have to find the friction. So F equal to V square divided by 127 or minus 0.07. The value is 0.087. So it is less than 0.15. So you have to take that the design say fixed super elevation of 0.07 provided of 0.07. So you can provide the super elevation up to 0.07. So the next topic is transition curve. So transition curve is nothing but it is introduced between a straight and circular curve. So it not be a straight, it's between straight and circular. Okay. So where in the places we can provide the transition curve. It is three types is there. One thing is spiral and lemon skate. That one is lemon skate and third one is cubical spiral. Cubic spiral. Okay. There are three types of transition curve is there. Here the thing is we have to calculate three transition curve. Then we can find the transition. The LS stand for transition curve. So we have to find the three LS, and finally in the three LS, which one is larger? You have to use that LS to find the shift. Okay. So in the transition curve, you have to find the three LS and one shift. Okay, you have to find the shift by using which is the largest LS. That LS is your LS for shift calculation. Okay, so first LS you can calculate it by the formula, that is LS equal to V cube by CR. There is separate formula for C, that is 80 divided by 75 plus V. Once they are provided, that is the C is provided. C is provided means you don't need to find that. Okay, you directly take account that value in 8LS formula. Okay, so V value is 80. So totally you have to you have to use that formula, and if you find the C value, after you can substitute that value in transition curve formula. Okay, you can find the first transition curve, and the next thing is rate of change of super elevation. You have to first one you are find the length of transition curve, that ls, and next thing rate of change of super elevation ls. Okay, the formula for that is ls equal to en divided by 2 into W plus WE. Okay, widening plus extra widening. Okay, so what is extra widening? I will continue from next slide. Okay, just now you take this account to your problem point of view. That is LS equal to En divided by 2 into W plus W. That is width of payment plus extra widening of payment. So this is what LS, and where is payment is rotational. That is LS equal to En into W plus WE. Okay. So here W is normal width of payment, WE is extra widening, and E is rate of super elevation. Same. What is the super elevation? You have to find the super elevation and you take that answer in that account, and N equal to rate of change in super elevation. That is 150 in plain and rolling terrain, 60 in hilly terrain. Okay. And the next LSS, you have to find as empirical formula. If it is plain terrain, means the formula is LS equal to 2.7 V square divided by R. If it is mountain or steep, means the formula is LS equal to V square divided by R. Okay. And I told after the transition curve finding, you have to calculate the shift. The formula is S equal to transition curve square. Which of the transition curve value you get more higher means you have to mention that LS in your shift formula, that LS divided by 24 into radius. Okay, so now you can see the two. Now we are going to see two things. One thing is extra widening, and another one thing is transition curve problem. Okay, first we will see the extra widening. So okay, we'll go here. So yeah, this is a shift of shift of transition curve is already told you from this book. How long this we can see. Calculate the length of transition curve and shift of transition curve. Given the data is design speed is 65 kilometer, radius of circular curve is 220 meter, width of pavement is 7.5, allowable rate of introduction super elevation is 1 in 150. Okay, so the given, first you write the given value, that is 65, and our radius is 220, and what is your width of payment is W plus WE, including the extra widening. So normal 3.5, 7 meter is road length, and the 0.5 is extra widening, WE, that is 7.5 meter. Okay, first you have to calculate the length of transition curve, LS based allowable rate of centrifugal acceleration, that is C. C is nothing but allowable rate of centrifugal acceleration. That is, the formula is 80 divided by 75 V. That is, V is nothing but what is the speed you are you are getting in your question. Okay, so 80 divided by 75 plus 65 is our answer is 0.57 meter per second cube, cubic second. Okay, so as we know, that is 0.05 less than C is less than 0.08, so C equal to 0.57. Okay, so next thing is LS. If your answer is more than 0.8, means you have to restrict the C value to 0.8. Okay, so that is mentioned here. And the next thing is LS equal to, you have to find another LS, that is 0.215 V cube divided by C into R, your formula, you have to use this 0.0215 into 65 cube, your C value is 0.57 into 220, and your answer is 47.1. And next thing is length of allowable rise of indentation super elevation, that is E equal to V square divided by 225 R, and your speed is 65. So you provide that speed 65 divided by 225 into 220, you are getting the answer is 0.085. Your super elevation is 0.085. It is more than 0.07. So you restrict that value to 0.07. And next it was lateral friction F. F equal to V square divided by 127 R minus E. And your speed is 65 square divided by 127 into 220 minus 0.07, and your answer is 0.081. If it is F equal to 0.081 is less than, it is less than 0.15, so you can take that E equal to 0.07 is safe design speed. So from that you can take total rise of outer edge, that is E into B, that is 0.07 into 7.5 divided by 2, that is 0.26 meter, and the rate of indentation of super elevation is 1 in 14, that is LS equal to En divided by 2, that is already you are find the value is 0.26. So 0.26 into 150, you will get 39 meter. And the length as per IRC formula, the IRC formula is LS equal to 2.7 V square divided by R, that is 2.7 into your speed is 65 divided by 220, your answer is 51.9. So here you can see, compare the value, LS value, the highest value is 51.9, that is you can see here the LS from here onwards, you can see the LS value is 47.1, and here the LS value is 39, and here the LS value is 51.9. So totally, for shift finding, you have to find in that comparing all the values, in that which one is longer, which one is highest value, you have to use that value. So the length of transition curve is 52, and that is nothing but 51. It is equal, is normalized to 52. So 52 square divided by 24 into 220, your answer is 0.51 meter. So like that only we need to calculate your transition curve. So next, highway geometry design in vertical curves. So vertical curves provide in elevation at change of gradients. Okay, so if it is we can provide you provide if it is y angle, means there is one point is there and another one point ground level is there. There is two gradients is there. So it is provided, vertical curves is provided in the elevation change of gradients. Okay, these curves are converged in two grades, meet the summit and concave when meets at sag. Okay, if it is positive grade, meet negative grades. If it is positive, meet another milder positive grade. Positive grade mean it's a level stretch, and negative grade means steeper negative grade. Okay, so this everything was based on your curve meets area. Okay, so the important thing is design of summit curve. Okay, how we need to design. So those things are very important. So you have to keep those formulas in your mind. Okay, so it's very important. So your summit curve you are compared with your side distance. Here first the L is stand for total change of gradient with a rate of change of grade. Okay, that is G1 minus G2. The ratio between total change of grade and rate of change of grade. Okay, so your L value is greater than SSD, which means a shorter side distance. Okay, means you have to use the following formulas, that is L equal to ns square divided by 4.4. Okay, so L equal to, you have to use this formula. This is L equal to ns square divided by 4.4. This formula you will get it from here. That is L equal to ns square root of 2 1 plus root of 2h whole square. Okay, 2h square. Okay, so you can directly write it into L equal to ns square divided by 4.4, and s is nothing. S is nothing but stand for shorter side distance, and h is stand for height of high level of driver 1.2 meter as per IRC, and h height of object 0.15 meter as per IRC. Okay, so these are the following things stand for. I think this is nothing but L equal to n square divided by root 2 capital H plus root 2 small h. Okay, this whole square here I use that bracket, so here also bracket will come. Okay, and your case 2 L is less than SSB. Okay, if your L is less than SSB, shortest side distance, means you need to use the following problem, that is 2s into root of 2h plus root of 2 small h to whole square divided by n. Already you know the h is height of high level of driver, that is 1.2. H is height level of object, that is 0.15 meter. Okay, the s is nothing stand for SSD. So whether you get some problem based on this, is first of all you need to calculate the SSD. Okay, you need to find the SSD and compare that value with your L. Okay, change of ratio between total change of gradient and the rate of change of grade. You have to compare your value with that. If it is greater than or less than, if it is less than means you are if it is less than means you have to use this formula, that is L equal to 2s minus root of 2h plus root of 2 small h divided by n. Okay, if it is greater than means you have to use the above mentioned formula, and you can solve is 2s minus 4.4 divided by n also. N is the number of lanes. And the length of summit curve, it is compared with overtaking side distance. When L is greater than OSD or ISD, intermediate side distance, is L equal to n square divided by 8h, which is nothing but L equal to n divided by x square divided by 9.6. Okay, and case 2, when L is less than OSD, so when it is less than OSD means L equal to 2s minus 8h divided by n, that is nothing but 2s minus 9.6 divided by n, number of lanes. Okay, the maximum radius of parabolic summit curve, it is r equal to L divided by n naught. So these are the formulas are important for solving the one problem based upon this. So, and last topic is in your geometric design, that is design of valley curves, and cubic parabolic is generally performed in valley curves. Based on in your valley curves, most probably there is cubic parabolic shape will be there. That is L equal to 2 into Ls. That is, you can take your LSS formula is already that is any transition curve formula is you have to find the transition curve. Okay, so that is 2 into LS is equal to 2 into NV cube divided by C is all to the power of 1 by 2. That is nothing but 0.38 into N V cube is all to the power of 1 by 2. You can use this formula what data here. If you have n and if you have the speed means you directly use this formula L equal to 0.838 nv cube and all to the power of 1 by 2. If you did not have this, if you have the c value, this coefficient value means you can go with this formula also. Otherwise, you can go with 2 into ls also. You can find any one ls and you can use this answer. Okay. So that the three different formulas there, you can use any one to complete this. Minimum radius of valley curve of cubic parabola, that is r equal to ls divided by n. Okay. Or you can find this L divided by 2 into n. You can use any one formula. Okay. So next thing is side distance. If there are two cases is there based upon side distance, two cases, and the L is less than SSD and L is sorry, L is greater than SSD and L is less than SSD in valley curve. So the formula is L equal to Ns square divided by 2H1 plus 2 into tan alpha. Okay. This is Ns square equal to H is that is 1.5 plus 0.035. Yes, you can use this thing also. In our case 2, if L is less than or SSD, L equal to 2s minus 2h1 plus 2s to tan alpha divided by n. Okay. So here the alpha is nothing but that is beam angle. Okay, minus 1 degree as per IRC, and h1 is nothing but need light height, that is 0.75, and the rest of the things is you are already know it is standard for deviated angle. Okay, it is nothing but deviation angle. N dash is stand for gradient of initial tangent. S stand for location from initial tangent, and S equal to N1 divided by L divided by N. So next important thing is setback resistance and curve resistance. From this, your geometric design will topic will end. Okay. So these are the problematic topics, and rest of the another problematic topic is design of rigid pavement and flexible pavement. On our next class, we are discuss about that our design, and the rest of the theory topics will we can take that on this class. Okay. So now we can end our section by this topic, that is setback resistance and curve resistance. And first thing is curve resistance. The loss of transitive force uh, due to turning of the vehicle on horizontal curve. Okay? The loss of transitive force, okay, when we lost that force due to the turning effect, okay, on the horizontal curve, that is, we can take it as t into 1 minus cos alpha. Okay, that is alpha is nothing but turning angle, t is actual tractive force. And next one is setback distance. We can mention it in M, that is certain offsets or setback from an obstruction to the central line of road must be available to provide adequate side distance. Okay, so setback is nothing but it's an offset. Okay, from the obstruction, it need to provide on the road. Okay, must be available to provide adequate side distance on the curve is called a setback. The formula we can use to calculate that is n equal to x squared divided by 8r. Okay, when the length of curve is less than side distance M equal to 2s minus L divided by R. Okay, S is nothing but shift. You can calculate the shift now. Okay, that is yes. You can find the shift and you use that shift value with the formula and you can find the setback distance. So the very important topics in your in point of view, definitely you can expect one or two questions in those area, geometric design. Definitely they will ask side distance problem or overtaking side distance problem or transition curve problem or super elevation problem. You can expect any one type of problem for your gate exam. So we give some examples also. Just you can refer, okay, and if you needed more examples means I will give that same. You can use Kannan and Gusto for transportation engineering, for highway engineering books is there. You can use that book, it is good. In that book they solve different types of problems is there. You just go through that book if you get enough time. Okay.
Sir, can you repeat the name, sir?
Kannan and Gusto.
Okay, sir.
Anna Investor. This book is a good book. You can go and use that book. And another one book is also there, that is Subramania, but it is written by the author in Anana City, Chennai. But that book also is too good. They also solve the different problems, but some mistakes in that book. They mentioned some meter, centimeter, some mistakes is there. Once you read out, you can able to rectify. You identify what are the mistakes is done. But otherwise, it's a good book. You can easily understand by using the book. That they solve the problem in an easy way. And I give one problem for you. During this study material, I included that and I sent it to you also. You can go through that. Okay. Apart from this, there is geometric. The another one important thing is that is extra widening of curve. Okay, so the extra widening of curve is nothing but I need to tell two things for you. I didn't I missed that so, but I will tell the two things. One thing is extra widening of curve. Extra widening of curve is nothing but in our normal bit there is for a single lane means we can provide up to 3.5. If it is double lane means it will extend up to 7 or 7.5. But in curve area, we will not provide the same. We need to give some extra width for the road. So that is called as extra widening. Okay. So a minute. I will tell the formula for extra widening. You can note it. It is not mentioned here. Yeah. Kindly note it. So the extra widening the mechanical extra widening is two things incorporate. One thing is mechanical widening, another one thing is psychological widening. The mechanical widening formula is Wm equal to NL square divided by 2R. Wm equal to NL square divided by 2R. Wm mechanical widening plus psychological widening. The formula for psychological widening is V divided by 2.64 root R. Okay. V divided by 2.64 2R. That is, extra widening is nothing but mechanical widening plus psychological widening. That is nothing but extra widening equal to NL square divided by root R plus V square divided by 2.64 root R. Okay. In the study material, I will add that page also. Okay, I will send it to you. Just you can see it's enough. Okay, it's very easy one only. But some cases, if they ask that kind of questions, you can to miss. So keep it in that mind. And another one thing is that is intermediate side distance. I already mentioned there are 3 types of side distances there. One thing is intermediate side distance. We can calculate, I give the example problem for a stopping side distance and overtaking side distance, but I didn't mention anything about intermediate side distance. Intermediate side distance is nothing but 2 into your SSD, 2 into stopping side distance. What the answer you are getting for your stopping side distance value into twice into 2 is your intermediate side distance. Okay, for that one I didn't mention any separate thing for that. So intermediate side distance is nothing but 2 into SSD. You can note that also. Okay, I mentioned that too. Okay, so these two things you have to keep on your mind. So I think today's section is we can end our today's section. If you have any doubt, you can ask.
Sir, other than this geometrical design, side distance, super elevation, and overtaking side distance, which topics can we expect for this gate exam, sir? For
Uh,
theory purpose.
for theory part, in particular in geometric design, definitely they will. I think I wrote the gate exam in 2 times. With the 2 times, I faced the question in stopping side distance.
Okay, sir.
And both the time I will see that question, and you can expect transition curve problems also, because in this topic comparatively other topics transition curve is a little bit work you have to put more. So they may ask this question in your uh, detailed question.
Okay, sir.
So you can give importance for transition curve, and you can give your importance for super elevation also, and overtaking side distance and SSDs they frequently ask in one
Okay.
mark. One question is there in SSD. So yeah, you give importance for SSD also.
Okay,
Uh,
sir.
and another important topic is highway is design part. Okay, so we will conduct in next class we are going to discuss in that design area.
Okay, sir. Thank you, sir.
Definitely you have nearly 10 marks in transportation engineering. So it is very easy scoring area. One subject is transportation, another one is construction planning and scheduling. So those are construction materials. These are easy scoring area. So don't miss any marks in this area.
Okay, sir. Okay, sir.
Are there any questions? I think I complete the section before 5 minutes. I think so. Sir, am I right?
Sir, yes, sir, no issue, sir. Students, if you have any queries, kindly discuss with, interact with the experts, sir.
Sir, please share this PPT to group, sir.
Yeah,
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 sure.
yeah. I will give. Sir, I missed to discuss 2 topics, sir. I include that topic also, and
Yes,
I
sir. So
send
we
that.
have no, sir. So we have one more session, sir, for the next week.
Okay, okay.
Yeah,
Yes,
the
sir.
same day we will discuss
Yeah,
queries
yeah.
also on this.
I
Yes.
included that also
Yeah, yes.
in my notes, and you give it to them. Sir.
Yes, sir. Yes, sir. Okay, sir. Okay. Students, if you have any queries, any comments means kindly make a message to my number. I will forward to the expert, sir, and we will discuss.
Sir,
Okay.
can I share my mail ID, sir? If there is any issue, if there is no
Yes, sir.
issue,
No issue, sir. You can post your mail ID in chat box, sir.
you
Yes.
can ask any question to this mail. If any time if you need any notes or some other subjects also, what I have, I will send it to you. Okay, you can ping me. I will send.
Yes, sir. Okay. Thank you for your presence, sir. Students, notes are mail ID, and if you have any queries, any material needed means, just you can directly contact to this, sir. Okay. Thank you, sir. We will wind
Thank
up
you
the
so much,
today's
sir.
session, sir. Yes, yes.
Thank you so
Thank
much.
you, sir.
Sir,
Thank you.
kindly ask the feedback, sir. If it is,
Uh,
your feedback is very important for me
yes,
because
yes,
it will make me improvise myself.
definitely,
Right.
sir. So anyone, you can share your open feedback to sir directly about today's session.
Sir, as up to now, we were confused of GATE exam, sir, because it is very near to now.
Yes,
Only 45 days left for the examination. I was confused of this GATE examination, sir. Mainly transportation engineering is very helpful for this today's class.
yes.
You totally gave a clear idea about transportation engineering, sir. I'm very thankful for your class, sir. This helps me a lot, sir. Thank you so much.
Yeah, thank you so much. Yeah, first of all, I also thank for this management to give this opportunity for me to take this section. Thank you so much, sir. It's a good one, good move for the
Yes,
students.
sir.
Yeah, sir. If it is possible, if it is for only your college students only, sir. This is for
Yes, sir.
your college.
Here, internal students only available, sir. Present third year and second year and final year, sir.
Oh, good.
Yes.
So move. Meeting. Have a good day.
All are busy with some official work, sir. For that reason, count is very less, sir.
Okay.
Yes, sir. Yes, sir. Okay, sir. Okay. Okay,
Thank
sir.
you.
Thank you. We will meet in the next session, sir. Thank you. Thanks to all. Yes, sir. Yes, sir. Boys, you can leave this class.
Okay, sir. Thank you.
Thank you.